So today we are going to see with start with exercise 9.4 here. So 9.4, what is this exercise 9.4? It's nothing but solving the differential equation and finding the solution for that. So when you find the solution, you have the general solution as well as a particular solution. So what is this general solution actually? It's nothing but the solution which involves arbitrary constants. That only we call it as a general solution. So y is equal to sin x plus a constant you have here. Okay, so this we call it as a general solution. So here when you are able to find out the constant value by substituting certain constraints actually here, that we call it as a particular solution here. You understood? Okay, so here there are so many ways of finding the solution for the differential equation. Here we are going to use the variable separable method in this case. So what is this variable separable method here? Okay, so here what is this variable separable method? As the word suggests here, you are going to separate it variable wise actually here. So what are the variables involved in this question here? You have only two variables, one is y and the other one is nothing but x here. So you will have to separate it according to the variable here and then integrate it with respect to the respective variable and then find the general solution of the differential equation. So you have two parts in this. The first few questions are the general solution and the next few are nothing but the particular solution here. Okay, so as I told you, your general solution, it involves arbitrary constants here. Arbitrary constants are nothing but the solution which is involved there. Okay, so here what is the solution which is involved here? So y is equal, the constants which is involved. So y is equal to sin x plus c. So here this c we call it as an arbitrary constant. For example, if I have it as y equal to a into cos x plus b. Here if you see a and b are nothing but the constants here. Okay, so depending on this constant, your order of the differential equation also will vary. If you have one constant, the order of the differential equation is nothing but 1. If you have two constants, the order of the differential equation is nothing but equal to 2. Since your exercise 9.3 is omitted, that is formation of differential equation is omitted there actually here. So we are not going into the depth of what is meant by arbitrary constants and etc. there. Okay, so here we'll go to find out the solution by the variable separable method. So questions 1 to 10, you will have to find the differential, for each of the differential equation you will have to find out the general solution. So we'll see how we can find out the general solution here. The first question, dy by dx is equal to 1 minus cos x divided by 1 plus cos x. So here as I told you, it's a variable separable method here. First, when a differential equation is given here, see if you can split the y terms to one side and the x terms to the other side, preferably y terms in the left hand side and x terms in the right hand side here. So what have you got actually here? Your dy is equal to 1 minus cos x by 1 plus cos x into dx. So we have split it here. Okay, now here the next step is what? You'll have to integrate it. So when I integrate it, you will have it as integral of dy is equal to integral of 1 minus cos x by 1 plus cos x dx you get. So here your y is equal to integral of 1 minus cos x is what? 2 sin squared x by 2 divided by 2 cos squared x by 2. That's nothing but the trigonometric identity there, dx. 2 and 2 gets cancelled there, which is equal to integral of tan squared x by 2. So integral of tan squared x by 2, it's not possible for us to integrate it straight away. So what is the identity? Because I don't know what is integral of tan squared actually here. So using the trigonometric identity, we'll write it as integral of secant squared x by 2 minus 1 dx. So here your y is equal to, when I integrate this, you will have it as tan x by 2 divided by 1 by 2 minus integral of 1 is nothing but x plus a constant. Okay, so y is equal to, when this goes to the numerator, you have it as 2 tan of x by 2 minus x plus c, which is said to be the general solution. So as I told you earlier, the general solution, it involves a constant here, an arbitrary constant. That only we call it as a general solution for this differential equation. Okay. Now here the second question, your dy by dx is equal to square root of 4 minus y squared. So here since it's the first method, the variable separable method, you will not have any confusion. But after this, as we go further exercise, you may have a confusion by what method we have to solve the differential equation. That's why I tell you first step, when a differential equation is given and if the solution, whether it's a general solution or the particular solution which is asked there, check if you can separate it variable wise. That is y terms to one side along with di and x terms along with dx to the other side. So here you have dy by dx is equal to square root of 4 minus y squared. Now we'll just segregate it here. Dy divided by square root of 4 minus y squared is equal to dx. When you cross multiply, what will you get? It's nothing but dx. So here we'll just integrate it both sides. So integral of dy divided by square root of 4 minus y squared is equal to integral of dx. Now what's the formula I'll have to use here? It's nothing but integral of dx divided by square root of a squared minus x squared. What is it equal to here? It's nothing but sine inverse of x by a plus a constant. So what will I have here? It's equal to sine inverse of your x is nothing but y divided by your a. What is your a here? It's nothing but 2, which is equal to integral of dx is nothing but x plus a constant. Okay, so here this is what you have here. So here you will have y by 2 is equal to sine of x plus c. So y is equal to 2 into sine of x plus c is said to be the general solution. Okay, so here this is the general solution. Got it? Yes. Now here we'll go over to the third question here. Your dy by dx plus y is equal to 1. Okay, so dy by dx plus y equal to 1. Saying it itself, you know, it's a differential equation here. So we'll have to solve and find the general solution. So we'll separate it by the variable separable method here. So what will I do here? Dy by dx is equal to, when I take this to the other side, you will have it as 1 minus y, which implies here your dy divided by 1 minus y is equal to, when you cross multiply here, you will have it as dx. Okay, so dy by 1 minus y is equal to dx. Now integrating it with respect to, with whatever it is. So here integral of dy divided by 1 minus y is equal to integral of dx. So what is integral of dy by 1 minus y? It's nothing but equal to log of 1 minus y divided by the coefficient of y. What is the coefficient of y? What will you get? It's minus 1, which is equal to integral of dx is nothing but x plus a constant. So what will you have? It's minus log of mod 1 minus y is equal to x plus a constant. This is what you have here. Now here I've already told you under integration your e power log x is nothing but equal to x here. So here I can write this as e power, okay, so here when I write this as e power, what will I get here? This minus sign, of course, when I take it to the other side, you will have it as minus x plus a constant. So e power log of 1 minus y you get here, which is equal to e power minus x plus a constant. Okay, so what is this e power log of 1 minus y? That's nothing but equal to 1 mod of 1 minus y. I can also write it as, since it's mod, I can change and write it as y minus 1 is equal to e power minus x plus c is what you have here. So taking it to the other side, you will get y is equal to 1 plus e power minus x plus c. So here this will be called as the general solution. Again I'm telling you, a general solution, it involves nothing but arbitrary constants. Okay. Here the fourth question. So what's the fourth one you get here? Integral of secant square tan y dx plus secant square tan x dy is equal to 0. So here again it involves a variable x and y here. So as I told you earlier, we'll just segregate it. So first I'll just take it to the right hand side. So you can write it as secant square tan y dx is equal to minus secant squared y tan x. This is what you have here. Okay, tan x dy. So we'll take all the x terms to one side and the y terms to the other side. So you have it as secant squared x. This comes to the denominator. It is tan x, which is equal to here minus secant squared y by tan y dy. So this is the first step. Always you'll have to do under the variable separable method here. Okay. Now the second step is what? Integrate it here. So integrating both sides. So when you integrate both sides, what will I get? Integral of secant squared x by tan x dx, which is equal to integral of minus secant squared y by tan y dy. This is what you have here. Okay. Now we'll see how we can integrate it. Yeah. So now I think you must be used to the integration methods also here. So what is the method we have here? The method by substitution here, because your differentiation of the denominator gives the numerator. What is differentiation of tan x? That's nothing but equal to secant squared x. So I can put t is equal to tan x. Your dt by dx is equal to secant squared x you have here. So your dx is equal to dt divided by secant squared x. Since I've already used t here, the same way for y also you have here. I've used a substitution here, but in terms of y, the same thing in y I have repeated, nothing else. Okay. So here this is equal to integral of secant squared x by 2. Okay. into dt divided by secant squared x, which is equal to integral of minus secant squared y by u into du divided by secant squared y. Of course, it gets cancelled here and you're left with what? Integral of dt divided by t, which is equal to minus integral of du divided by u. So what will I get? Log t is equal to minus log u plus a constant. Now, I'll just take this to the other side. See here, why I write it as log c. If you have logarithmic throughout, otherwise don't use log actually here. If I have logarithmic throughout, I can just write it as plus log c here. So you have it as log tan x. When I come to the other side, it's plus log of tan y is equal to log c. Okay. Now here, log of tan x into tan y is equal to log c you get here. Now here what will happen here, it will be nothing but your tan x, eliminating the log you can write it as your tan x tan y is nothing but equal to c. You understood? The fifth question here. So what's the fifth question you have? E power x plus e power minus x into dy minus of e power x minus e power minus x into dx is equal to 0. Okay. So here again it's by the variable separable method. If it's a differential equation, don't always expect it must be in the form of dy by dx etc. here. Not like that. Okay. So it can be like this also here. So here first of all I'll just take this to the right hand side. So what will you get? It's e power x plus e power minus x into dy is equal to e power x minus e power minus x into dx. So what will I have? Your dy is equal to e power x minus e power minus x divided by e power x plus e power minus x dx. Okay. Now integrating both sides. So when I integrate both sides, what will I get? Integral of dy is equal to integral of e power x minus e power minus x divided by e power x plus e power minus x dx. This is what you have here. Now here if you see, you've got it like this. So what is a method I can do here? Yeah, just differentiate this and see. When I differentiate it, you will have it as e power x. When you differentiate this, you will have it as minus e power minus x. It's nothing but the numerator here. So what's a method I'll have to use here? I'll have to use a method by substitution. What's a substitution you will put? T is equal to e power x plus e power minus x. So what is your dt by dx is equal to e power x minus e power minus x. This is what you have here. So what is your dx equal to there? dt divided by e power x minus e power minus x. So you will have integral of dy is nothing but y equal to integral of e power x minus e power minus x divided by t into dt divided by e power x minus e power minus x. So here it's equal to, this gets cancelled, it is equal to integral of dt divided by t. So what is integral of dt divided by t? That's nothing but log t. So you can write as y equal to log of t plus a constant. Don't forget the left hand side. Don't simply write it as equal to. That will not be the general solution. Okay. So y equal to log of e power x plus e power minus x plus a constant is said to be the general solution for this differential equation. This is a general solution. Got it? Yes. Now the sixth question. So what is your sixth question here? dy by dx is equal to 1 plus x squared into 1 plus y squared. So this is easy for us to separate the variables here, one as y and the other in terms of x here. So you will have it as dy divided by, when I cross multiply, you will have it as 1 plus y squared, which is equal to 1 plus x squared into dx. This is what you have here. So you have it as integral of dy divided by 1 plus y squared is equal to integral of 1 plus x squared dx. So you integrate this. You know the formula. What's the formula you get here? Integral of dx divided by 1 plus x squared. What is it equal to here? It is equal to tan inverse of x. This is what you have here. So I can write this as tan inverse of y, which is equal to integral of x, 1 is nothing but x plus integral of x squared is nothing but x cubed by 3 plus a constant. Okay. The seventh question here, it's y log y dx minus x dy, which is equal to 0. Okay. So another differential equation is given to us here. So we'll see how we can do it by the variable separable method here. So what will I do? Your y log y dx is equal to, taking it at the other side, you can have it as x into dy. So here when I split the variables here, this x it comes to this side. So it is dx by x. Always remember the differential part must be in the numerator. Don't bring that to the denominator. If you bring it, you cannot integrate it. Okay. So it's dx by x, which is equal to dy divided by, when I bring this to the other side, you will have it as y into log y. Got it? Now we integrated both sides. So when I integrated both sides, you will get it as integral of dx by x, which is equal to integral of dy by log y. Now here this integration, you know what is integral of dx, it's nothing but log x. Coming to this part, you have it as dy by y log y. So here if you see, I have already asked you to check by the method of substitution if differentiation of one gives you the other. What is differentiation of log y? That's nothing but 1 by y. So what will I put here? T is equal to log y, you get your dt by dy is equal to 1 by y you have here. So you will have your dy is equal to y dt. So that's what I have substituted here, y dt divided by yt, so it gets cancelled. You're left with log x is equal to log t plus a log constant. I told you if you have log throughout, you can just put it as log c. Okay, just if you do not have that, please don't put it as log c there. So log x is equal to log of log y plus a constant, log constant you get. Taking it to the other side, you have it as log x minus log c is equal to log of log y you get here. So you can write it as log of x by c is equal to log of y. Okay. So what will happen here? You have it as x by c is equal to log y. This is what you have here. So x by c is equal to log y. So if I want to eliminate this, you know that if I take exponential both sides, this can be eliminated. So what is it actually here? Your e power log x. What is your e power log x? It's nothing but equal to x. So you can write it as e power log y is equal to e power x by c. In other words, I can say your y is equal to e power x by c. Got it? So this is the general solution for this differential equation. Okay, so it's a general solution for this differential equation. Got it? Yes. Now here the 8th question. So what is the 8th question you have here? X power 5 dy by dx you have here, which is equal to minus y power 5. This is what you have here. Okay. So when you see it itself, you will know it's a variable separable method here, because very easily you can segregate your y and x here. So when I segregate it, what will I get? It is x power 5 you have here dy. When I cross multiply, it's minus y power 5 dx. The variables are not in order here, so we'll just bring it in order. Dy divided by y power 5, which is equal to minus dx divided by x power 5. So what's the next step? I told you here, you'll have to integrate it both sides. Okay, so that is the next step you'll have to do here. So here, when you take it to the numerator, you will have it as y power minus 5 dy is equal to minus integral of x power minus 5 dx. This is what you have here. So what is your y power minus 5 equal to here? It's nothing but y power minus 4 divided by minus 4. Because what is integral of x power n dx? That's nothing but equal to x power n plus 1 divided by n plus 1. This is what you have here. So it's y power minus 4 divided by minus 4, which is equal to minus x power minus 4 divided by minus 4 plus a constant. Got it? Now here, I'll just bring it to the other side. You can have it as y power minus 4 by minus 4. Of course, it will become plus. But when I take it to the other side, it will be nothing but minus, okay, which is equal to a constant. So how do I write it? I can write it as y power minus 4 plus x power minus 4. When I cross multiply, you will get it to be equal to minus 4 into c. This is what you have here, okay. Now here, the 9th question. So what's the 9th question you have here? Your dy by dx is equal to sine inverse of x. So dy is equal to, again here, what is the next step I'll have to do here? Only by a variable separable method. So we'll just separate it. You have only one x term here. Dy is equal to sine inverse of x dx. So integrating it, you will have it as integral of dy is equal to integral of sine inverse of x into 1 dx. This is what you get. Why I have written 1 here? Already we have seen under the integration chapter, how do you integrate the inverse trigonometric functions? Only by parts here. Okay, so sine inverse of x into 1 you have here. So when I take parts, this will be the first one and this will be nothing but your second one you have here. So what is the formula? First one into integration of the second one minus integral of d by dx of the first one into integration of the second one with respect to x, and here you have it as dx. This is how you will have to integrate it. So what will I have? Sine inverse of x into integral of dx, because 1 is nothing but just dx, minus d by dx of sine inverse of x into integral of dx, whole thing with respect to x here. So you have it as x, integral of dx is what? X into sine inverse of x minus integral of differentiation of sine inverse of x. What will you have? X by square root of 1 minus x squared. This will be nothing but dx. Okay, because this dx only I have written it as x. Here I have written the dx here. Now how do I integrate it actually here? Yeah. So when you differentiate this one, 1 minus x squared, what will you get? Minus 2x. I've already told you, when you use a substitution method, when you differentiate the denominator, the coefficient is not a matter at all. So see if you get the variable here. So I've used a substitution. T is equal to 1 minus x squared. Your dt by dx is equal to minus 2x. What is your dx equal to here? Minus dt divided by 2x. So what will I have? X into sine inverse of x minus integral of x by root t into minus dt divided by 2x. So it gets cancelled. So x into sine inverse of x, minus into minus is nothing but plus 1 by 2 integral of, this goes to the numerator. So you can write it as t power minus 1 by 2 dt. Got it? So you will have it as x sine inverse of x plus 1 by 2 into, what's a formula you can have here? X power n plus 1 divided by n plus 1. So you have it as t power 1 by 2 divided by 1 by 2 plus a constant you get. So 1 by 2 and 1 by 2 it gets cancelled. So you will have it as x into sine inverse of x plus, what is the value of t here? 1 minus x squared. So you will have it as square root of 1 minus x squared plus a constant. So if you see here, this is the general solution for this differential equation. Don't forget this constant, children, here. Okay, that's very important here. Only then I can call it as a general solution here. Okay, so otherwise, the 10th question, e power x into tan y dx plus 1 minus e power x into secant square dy is equal to 0. Okay, so here this is what you have here. So e power x into tan y dx plus 1 minus e power x into secant square y dy is equal to 0. So we'll do it by the variable separable method. So what will I have? E power x into tan y dx is equal to, taking it to the other side, it's minus of 1 minus e power x into secant squared by dy. Okay, so here we'll just split it. What will I get? E power x divided by 1 minus e power x into dx is equal to minus secant squared by divided by tan by dy. Okay, now we'll integrate it both sides. So when I integrated both sides, what will I get? Integral of e power x by 1 minus e power x dx is equal to minus integral of secant squared y by tan by dy. Got it? So here both I'll have to integrate it now. So check. So here what is the method? Mostly it will be only by the substitution method here. So when I use the substitution method, so when I differentiate the denominator, you get the numerator. So what will I put? Put t is equal to 1 minus e power x. Your dt by dx is equal to minus e power x, and your minus dt by e power x is equal to dx. So u is equal to tan y, your du by dy is equal to secant squared y, and your dy is equal to du divided by secant squared y. So substitute it here. When I substitute it, e power x divided by t into minus dt divided by e power x, which is equal to minus integral of secant squared y divided by u into du divided by secant squared y. This is what you get here. So of course it gets cancelled. This also gets cancelled here. So it's integral of, what will I get here? This minus and minus also gets cancelled here. It's integral of dt divided by t is equal to integral of du divided by u. So what is this? It's log t equal to log u plus log of a constant. Okay. So substitute it. What will I get? Log of 1 minus e power x is equal to log of tan y plus log c. So how do I write it here? Log of 1 minus x is equal to log of c into tan y. What is the property we have here? Remember the logarithmic property. Log of mn is equal to log m plus log n. So here we are using this property here. So here when I cancel this log, you will have it as 1 minus e power x is equal to c into tan y. So here this is the general solution for this differential equation. Got it? So here from question number 1 to 10 we have seen the general solution. So from question number 11 we are going to find the particular solution here. So we'll see how we can find the particular solution. The particular solution is nothing but without the constants actually here. Okay. So we'll see how we can find out here. So it's given as x cube plus x squared plus x plus 1 into dy by dx is equal to 2x squared plus x comma y is equal to 1 when x is equal to 0. Okay, so here this is what is given here. So of course the method is the same. The variable separable method, you will have to find the general solution. Only after that I can find the particular solution here. So the steps are the same actually here. So here in this case there are few constraints given. What is a constraint given here? Y equal to 1 when x is equal to 0. So using this I'll have to find out the value of c after you find the general solution. So that will give you the solution, the particular solution here. Okay. So we'll see how we can do it here. First we'll just separate it. So x cube plus x squared plus x plus 1 dy by dx is equal to 2x squared plus x you have here. So I can write this as your dy is equal to, when I cross multiply, what will I have? 2x squared plus x divided by x cube plus x squared plus x plus 1 dx. This is what you have here. Now we'll just integrate it both sides. So when I integrated both sides, what will I have? Integral of dy is equal to integral of 2x squared plus x divided by, so here if you see you can simplify it actually here. Okay, so when I take x squared common here, you will have it as x squared into x plus 1 plus what will I get here? X plus 1 dx. Now here this can be written as 2x squared plus x divided by x plus 1 is common here. So it's x plus 1 into x squared plus 1 dx. This is what you have here. So now if you see here, this left hand side, it's easy for me to integrate it. You will just have it as y. Now my problem lies in the right hand side. How will I integrate it? Only then I can find the general solution. As I told you earlier, the first step is for to find the general solution there. So we'll see how we can find out the general solution first by integrating this one. So when you see this itself, you know by substitution it's not possible there. So when you see the what is it here? It's a rational function. So what is a method I can apply here? By the method of partial fractions. So by the method of partial fractions, I'll just take this integrand separately, split it by the method of partial fractions, integrate it, and then we'll find the general solution. So your 2x squared plus x divided by x plus 1 into x squared plus 1 is equal to a by x plus 1 plus bx plus c divided by x squared plus 1. You know the rules for splitting by partial fractions. One is linear and the other one is quadratic. So you have it as a by x plus 1 plus bx plus c divided by x squared plus 1. So what will you get? 2x squared plus x is equal to a into x squared plus 1 plus bx plus c into x plus 1. This is what you have here. Okay. Now put x is equal to minus 1. So when I put x is equal to minus 1, what will I get? 2 into minus 1 the whole square is nothing but 2 minus 1, which is equal to minus 1 the whole square will give you nothing but plus 1, that's nothing but 2. So what's the value of a you get here? 1 by 2. This becomes 0. Now we'll just equate the coefficient of x squared and x and find out the values of b and c. Equating the coefficient of x squared. What is the coefficient of x squared here? 2 equal to, what is the coefficient of x squared here? It's nothing but a. Here again you will have it as bx squared you get here. What's the coefficient of x squared? It's nothing but b. So you will have it as a plus b, which implies 2 equal to 1 by 2 plus b. So what's the value of b you get here? It is equal to 3 by 2. Got it? Now equate the constants. What's the coefficient of x here? X here. Coefficient of x. What is the x coefficient here? 1 equal to, here I do not have any coefficient of x. Only here I have here. So what will I do? Bx into 1. What is bx into 1? It's nothing but bx plus c into x. So what will I have? It is just cx. So what is it you have here? B plus c. So I can write it as 1 equal to b plus c. So 1 equal to, what's the value of b here? It's 3 by 2 plus c. Taking it to the other side, you will have it as 1 minus 3 by 2. That's nothing but equal to minus 1 by 2. Got it? So you will have y is equal to integral of a. What's the value of a here? A is equal to 1 by 2. So you can have it as 1 by 2 by x plus 1 dx plus, what is the next one you get? B. What's the value of b here? 3 by 2 x. Okay, what's the value of c? It is minus 1 by 2 divided by x squared plus 1 dx. So how do I write it here? It's 1 by 2 into integral of 1 by x plus 1 dx plus 3 by 2 into integral of x by x squared plus 1 minus 1 by 2 into integral of 1 by x squared plus 1 dx. Got it? So I can write it as 1 by 2 into log of mod x plus 1 plus 3 by 2 into, so how will I do it? Actually I'm not done the substitution here, but I've straight away started with the method. What will I put the substitution? Put t is equal to x squared plus 1. So you will get your dt by dx is equal to 2x. So what is your dx equal to here? It is equal to dt divided by 2x. This is what you have here. So y equal to 1 by 2 log of mod x plus 1 you get here, plus here it is 3 by 2 into x by 2 into dt divided by 2x minus 1 by 2 into what is integral of 1 by x squared plus 1, that's nothing but tan inverse of x plus a constant. So here this 2 it goes outside here, this will remain the same, no change in it. It's just half into log of mod x plus 1 plus 3 by 4 into log of mod x squared plus 1, because dt by t will give you what? T, log t you will get here. What is the value of t here? T is equal to x squared plus 1. So you will write it as log of mod x squared plus 1 minus 1 by 2 into tan inverse of x plus a constant. So till this whatever you have got is your general solution, but the question says I'll have to find the particular solution. So when you read the question, I told you beginning itself what is a constraint given here? Y is equal to 1 when x is equal to 0. So using this we are going to find out the value of C. So I have just written it again there. Y is equal to 1 by 2 log of mod x plus 1 plus 3 by 4 log mod of x squared plus 1 minus 1 by 2 into tan inverse of x plus a constant. So when x is equal to 0 and y is equal to 1, what will I get here? Your y equal to 1, you will get it as 1 equal to 1 by 2 into log of 0 plus 1, it's nothing but log 1, plus 3 by 4 into log of 0 plus 1 is nothing but log 1 here, minus 1 by 2 into tan inverse of 0 plus a constant. So what is your log 1? This will become 0. What is your 3 by 4 into log 1? That also will become 0. What is tan inverse of 0? That also will be nothing but 0 plus c. So finally what is the value of c you get here? C is equal to 1 here. So I'll have to substitute that in this one here. So when I substitute it, what will I have here actually here? It's nothing but y equal to 1 by 2 into log of mod x plus 1 plus 3 by 4 into log of mod x squared plus 1 minus 1 by 2 into tan inverse of x plus 1. Okay, so here this is the solution you have here. Got it? Yes. Now here the 12th question. What's your 12th question here? It's x into x squared minus 1 into dy by dx is equal to 1, where y is equal to 0 and x is equal to 2. Got it? So here again you will have to find the particular solution. See, when a constraint like this itself is given, it means that you will have to find the particular solution. So the first step you will have to find the general solution. Only after that you can find the particular solution here. Okay. So we will use a variable separable method here. X into x squared minus 1 into dy is equal to dx. When I cross multiply, it becomes dx here. So what is your dy equal to? Dx divided by x into x squared minus 1 you get. So this can be written as x into x plus 1 into x minus 1. So what's the next step I'll have to do here? I'll have to integrate it both sides. So when I integrate it, integral of dy is equal to integral of dx divided by x into x plus 1 into x minus 1. This is what you have here. Okay. Now here again you don't have a problem. Integrating it, you will just have it as y. Now here I'll have to integrate it by the method of partial fractions. So I'll just take this integrand and split it here. 1 by x into x plus 1 into x minus 1 is equal to a by x plus b by x plus 1 plus c by x minus 1. So what is your 1 equal to? A into x plus 1 into x minus 1 plus b into x minus 1 plus c into x plus 1. This is what you have here. Now put x is equal to minus 1. So when I put x is equal to minus 1, what will you get? 1 is equal to, what will I have here? B into, when I substitute it, it's minus 1 into minus 2. So what's the value of b you get here? It is equal to 1 by 2. Next is what? Next root is put x is equal to 1. You will take 1 is equal to, this becomes 0. This also becomes 0. You're left with c into 1 plus 1. That's nothing but equal to 1 by 2. Next put x is equal to 0 here. So 1 is equal to 0 plus 1 into 0 minus 1 is nothing but minus 1. So you will get it as minus a. Here again it is minus b. Okay, here if you see it will be nothing but c. Substitute the value. 1 is equal to minus a. Here if you see it's minus 1 by 2 plus here if you see it's nothing but 1 by 2. It gets cancelled. So what's the value of a you get here? It is equal to minus 1. So we'll just substitute it here. Y is equal to, because how do you get that y here? Integrating this, it will be nothing but y. So here your y is equal to integral of minus 1 by x plus 1 by 2 divided by x plus 1 plus 1 by 2 divided by x minus 1 dx, which is equal to integral of minus 1 by x dx plus 1 by 2 into integral of 1 by x plus 1 dx plus 1 by 2 into integral of 1 by x minus 1 dx. The next step is what? You can easily integrate it because you know everywhere I'm going to use this log here. Okay. So here I've just rewritten it again. Y is equal to minus log x plus 1 by 2 log of mod x plus 1 plus half into log of mod x minus 1. So here we're just a simplification part, nothing else actually here. Before applying the constraints there, I'll just multiply and divide because here also you have half, here also you have half. I'll just multiply and divide by 1 by 2. Here again I can write it as half into, here in this case what will I write? When I take half outside there, you will have it as log of mn. What is log of mn equal to actually here? Your log mn is equal to log m plus what will I get here? It's nothing but log n. So you will have it as log of x plus 1 into x minus 1. What is log of x plus 1 into x minus 1? That's nothing but log of x squared minus 1 plus log plus a constant. Here you just write it as a constant when it comes to the particular solution. So here this 2 when it goes here, you will have it as minus 1 by 2 log of x squared plus 1 by 2 into log of x squared minus 1 plus a constant. So this is your general solution. Of course you can write it like this: y is equal to 1 by 2 into, so what is the formula you get here? Log m minus log n. What is log m minus log n? That's nothing but equal to log of m by n. So how do I write it here? 1 by 2 into log of mod x squared minus 1 divided by x squared plus a constant. Okay, so here you have got the general solution in this case. Now I'll have to find the particular solution. For that I need to find out the value of c here. Okay, so here how do you find out the value of c? What is the constraint given here? Y is equal to 0 and x is equal to 2. Substitute it here. 0 is equal to 1 by 2 into log of 2 squared is what? 4 minus 1. That's nothing but 3 by 2 square. That's nothing but 4 plus a constant. So what is the value of c you get here? C is equal to, when I take it to the other side, it's minus 1 by 2 into log of mod 3 by 4. So what is your y equal to? Substitute it in this. Don't ever stop with c. You'll have to substitute it in the general solution. Only then you can find the particular solution here. So it is 1 by 2 log mod of x squared minus 1 divided by x squared minus 1 by 2 log mod of 3 by 4. So this is the particular solution. Got it? Yes. Now here the 13th question here. Cos of dy by dx is equal to a, where your a belongs to r, y is equal to 2 when x is equal to 0. Here again you will have to find only the particular solution in this case. Why is it if they are given a belongs to r? It means that a is nothing but a constant. Okay, so first we'll just split it by the variable separable method here. So when I split it, what will I get? Cos of dy by dx is equal to a. When I take it to the other side, you will get dy by dx is equal to cos inverse of a. Okay, so here this is what you have here. So you have it as dy equal to cos inverse of a into dx. Now integrating it, integral of dy is equal to, you know that cos inverse of a is nothing but a constant because it's clearly mentioned in the question that a belongs to r, which means that a is a constant. So I can just take it outside the integrand here. It's cos inverse of a integral of dx. When I integrate it, what will I get? Y is equal to cos inverse of a integral of dx is nothing but x plus a constant. Okay, so you've got the general solution in this case. So this is your general solution. Now we'll find the particular solution. For that the constraint is given y equal to 2 when x is equal to 0. So when I substitute it, 2 is equal to cos inverse of a into 0 is nothing but 0 plus c. So what's the value of c you get here? It is equal to 2. So when I substitute it in the general solution, you will have it as y equal to x into cos inverse of a plus 2, which is nothing but your particular solution. Okay, now here the 14th question. It's dy by dx is equal to y tan x, where y is equal to 1 when x is equal to 0. Got it? So again here you'll have to find the particular solution. So first step we'll find the general solution here. So when you find the general solution, we use a variable separable method here. Your dy is equal to y tan x dx. So I'll just bring the y term here. It is dy by y is equal to integral of tan x dx. So when I integrated both sides, integral of dy is equal to integral of tan x dx. So what is integral of dy by y? It's nothing but log y. You know what is integral of tan x? That's nothing but minus log cos x plus log c. Okay, so I can write it as log y is equal to, here again I am using the formula log m minus log n. What is it equal to here? It is equal to log of m by n. So how do I write here? Log c minus log cos x. I can write it as log of c by cos x. So what will I get? It's log of c into 1 by cos is nothing but secant x. So I can write it as log c secant x. So you will have y is equal to c into secant x you get here. So here this is your general solution. Now you will have to find the particular solution. What is the constraint you get here actually? Y is equal to 1 when x is equal to 0. So substitute it here. Y equal to 1. 1 is equal to c into secant 0. What is your secant 0 equal to here? It's nothing but 1. Okay, so you will get your c is equal to 1. So what is the particular solution here? When I substitute it in the general solution, you will get it as y equal to secant x you have here. So this one we call it as the particular solution. Okay, so y is equal to secant x, we call it as a particular solution. The 15th question, find the equation of a curve passing through the point 0, 0 and whose differential equation is y dash is equal to e power x into sin x actually here. Okay, so it's clearly given in the question. I'll have to find out the equation of a curve passing through the point 0, 0 and whose differential equation is y dash is equal to e power x into sin x. So I'll have to find out the value of y. So what is given to us here? Dy by dx is equal to e power x into sin x. So here again, okay, so in this case what all is given? I'll have to find out the equation of the curve is what? I'll have to find out what is y equal to. It will be in terms of x and y. That is what we mean by saying here y. Indirectly it means that I'll have to find out the solution of this differential equation. That is what we mean by saying here the equation of the line. So here if you see, are the constraints given to us? Yes. What is the constraint given to us? It passes through the point 0, 0. So it means that x is equal to 0 and y is equal to 0. So I'll have to find out the arbitrary solution, sorry, the general solution, and then I'll have to find out what is it here, the particular solution. So we'll see how we can integrate it here. Dy is equal to e power x into sin x. So integral of dy is equal to integral of e power x into sin x. So when I integrate it, what will I do here? I'll have to integrate it by parts. Okay, that's obvious. We have done a similar question under parts also. I've just taken it as I here, the name of the integrand. So here this is your first one into the second one. I've already written the formula also here. First one integration or into integration of the second one, minus integration of d by dx of the first one into integral of the second one with respect to x, the whole thing with respect to x. This is what you get here. So sin x into integral of e power x dx minus integral of d by dx into sin x into integral of e power x, the whole thing dx. So here sin x into integral of e power x is nothing but e power x itself minus integral of d by dx of sin x is what? Cos x into integral of e power x is nothing but dx. So again I have come to the same position where I'll have to integrate it by parts only here. So which is your first one? This is your first one and this is the second one here. So we'll just integrate it by parts and see what we get here. E power x into sin x minus of cos x into integral of e power x minus integral of d by dx of the first one cos x into integral of e power x dx. Okay, so it's e power x sin x minus what will I get here? E power x here, integration of e power x is nothing but e power x into cos x. Okay, minus, how do you get minus? I will tell you. Differentiation of cos x is what? Minus sin x. Minus into minus you will get plus, but you have a minus sign here. When I multiply that minus sign here, you will have minus here. Okay, e power x into sin x because differentiation of cos x. What is this actually here? It's nothing but your I. Okay, so here I've already taken it as I. So when I take it to the other side, you started with I equal to. So I plus I is nothing but 2I you will get here, which is equal to e power x into sin x minus e power x into cos x. So I equal to 1 by 2 into e power x sin x minus e power x cos x. So y is equal to e power x by 2 into sin x minus cos x plus a constant. Okay, so here if you see, this is your general solution. Okay, so in this case if you see, this we call it as a general solution. Now we'll find the particular solution, that is the general equation. Okay, see, an equation of a curve, I cannot have it as a constant or something like that, so I'll have to find out the value of c here. So what is the constraint? In the beginning itself I told you y equal to 0, x is equal to 0. When I substitute it, 0 is equal to e power 0 is what? 1 by 2 into sin 0 is nothing but 0 minus cos 0 is nothing but 1. So you will have it as 0 is equal to minus 1 by 2 plus c. So what's the value of c you get here? 1 by 2. So what is your y equal to? E power x by 2 into sin x minus cos x plus what will I get here? C. That's nothing but equal to 1 by 2. Is a 16th question. For the differential equation x by dy by dx equal to x plus 2 into y plus 2, find the solution curve passing through the point 1 comma minus 1. Okay, so here they have asked us to find the solution for this differential equation as well as the curve passing through the point 1 comma minus 1. In that case, it means I'll have to find out the general solution plus I'll have to find out the particular solution also. So what is the constraint given here? X is equal to 1, y is equal to minus 1. Okay, so we'll just do it here. X by dy by dx is equal to x plus 2 into y plus 2. So when I segregate it, you will have it as y by y plus 2 into dy is equal to x plus 2 by x into dx. Now integrate it both sides. So when I integrate it, what will I get? Integral of y by y plus 2 dy equal to integral of x plus 2 by x dx. Now here if you see, it's not possible for us to do it by substitution here. So when you get a linear form like this, somehow or the other, try to bring whatever you have in the numerator. So what will I do here? Add and subtract 2 here. So y integral of y plus 2 minus 2 divided by y plus 2 dy is equal to, when I segregate it, you will have it as integral of x by x plus 2 by x dx. So here when again it's integral of y plus 2 by y plus 2 minus 2 by y plus 2 dy is equal to integral of x by x is what? 1 plus 2 by x dx. Got it? So here what will happen here? This gets cancelled. So you will be left only with integral of dy minus 2 into integral of 1 by y plus 2 dy is equal to integral of dx plus 2 into integral of 1 by x dx. So what is your integral of dy? It's y minus 2 into log of mod y plus 2, which is equal to x plus 2 into log mod x plus a constant. You understood here? So we have got the general solution. Now we'll find out the particular solution, that is your curve. Okay, find the solution curve. I'll have to find out. So in the beginning itself I told you this is your constraint. X is equal to 1 and y is equal to minus 1. So what will I get here? In this case, when I substitute, it's minus 1 minus 2 into log of minus 1 plus 2 will give you 1, which is equal to 1 plus 2 into log 1 plus a constant. So this becomes 0. This also becomes 0. You are left with minus 1 is equal to 1 plus c. So when I take it to the other side, you will get c is equal to minus 2. So we'll just substitute it here. Y minus 2 into log of mod y plus 2 is equal to x plus 2 into log mod x minus 2. So taking this to the other side, y minus x, and take this to the other side. By using this logarithmic power rule, I can write it as log of m power n is equal to n into log m. This is what you have here. So I can write it as log of y plus 2 the whole squared plus log of x squared minus 2. Take this to the other side. What will I get? Y minus x plus 2 is equal to log of y plus 2 the whole squared into x squared. So this is the solution curve passing through the point 1 comma minus 1. Got it? The 17th question here, find the equation of a curve passing through the point 0 comma minus 2, given that at any point x comma y on the curve, the product of the slope of its tangent and the y coordinate of the point is equal to the x coordinate of the point here. Okay, so here I'll take x as a x coordinate and y as a y coordinate here. So what is given here? Product of the slope of the tangent and the y coordinate. You know what is the slope? Generally under equation and tangents, that itself you have studied. Your slope is nothing but equal to dy by dx. So what will I write here? Product of the y coordinate and the slope is equal to the x coordinate. That is what is given here. See here, product of the slope of its tangent and the y coordinate of the point is equal to the x coordinate. Okay, and I'll have to find the equation of this passing through the point 0 comma minus 2. It means that your x is 0 and your y is equal to minus 2. So segregated, y into dy is equal to x into dx. Integrating it, you will have it as integral of y dy is equal to integral of x dx. You will have it as y squared by 2 is equal to x squared by 2 plus a constant. So far you have found the general solution here. Now I'll have to find out the curve. So what is the constraint given? X is equal to 0 and y is equal to minus 2. Substitute it here. You will have it as 4 by 2, because minus 2 the whole squared is what? 4 by 2 equal to 0 by 2 plus a constant. So you get c is equal to 2. So what is that you have here? Your y squared by 2 is equal to x squared by 2 plus 2 you get here. When I take it to the other side, you will have it as y squared minus x squared divided by 2 is equal to 2. Cross multiplying it, you will get it as y squared minus x squared is equal to 4. So here if you see, this is the curve. Okay, so here passing through the point 0 comma minus 2. So here this is the equation of the curve. The 18th one, at any point x comma y of a curve, the slope of the tangent is twice the slope of the line segment joining the point of contact to the point minus 4 comma minus 3. Okay, find the equation of the curve given that it passes through minus 2 comma minus 1. So here it will be a little confusing because there are 2 points, but read the first part actually here. At any point x comma y of a curve, slope of a tangent. So what is meant by slope of a tangent in general? It's nothing but your dy by dx, you know here. It is twice the slope of the line segment joining the point of contact to the point. So what is the slope here actually here? You will just write it as your y2 minus y1 divided by x2 minus x1. So here in this case you will know what is your x1 comma y1. What is this x1 comma y1? It's nothing but this. But what is the other point actually? The point of contact. This point of contact we'll have it as x comma y. Okay, so we'll have it as x comma y. So that is equal to twice of this one. That is what is given. So first we'll find out the slope. It is equal to y2 minus y1 by x2 minus y1, which is equal to y minus of minus 3 divided by x minus of minus 4. So you will get it as y plus 3 divided by x plus 4. So what will I get here? Your dy by dx is equal to 2 into y plus 3 by x plus 4. So here, and now come to the second part. Find the equation of the curve given that it passes through minus 2 comma 1. So it means that your x is equal to minus 2 and your y is equal to 1. Okay, so by using the variable separable method, first we'll find the general solution here. So you will have it as dy divided by y plus 3, which is equal to 2 dx divided by x plus 4. So integrating it, you will have it as integral of dy by y plus 3 is equal to 2 into integral of dx by x plus 4. You will have it as log of mod y plus 3, which is equal to 2 into log of mod x plus 4 plus log c. So you have it as log of mod y plus 3 is equal to log of x plus 4 the whole square plus a constant. Got it? Now here when I take it to the other side, you will have it as log of y plus 3 minus log of, what will I get here? X plus 4 the whole squared is equal to log c. This is what you get. So what is log m minus log n? You can write it as log of mod y plus 3 by x plus 4 the whole squared is equal to log c. So here when I take off the log, you will have it as y plus 3 divided by x plus 4 the whole squared is equal to constant. Now what is a constraint you have? X is equal to, this is your general solution here. Okay. Now here find out x is equal to minus 2 and y is equal to 1. When I substitute it, what will I get here, ma? 1 plus 3 is nothing but 4 divided by, what will I get? Minus 2 plus 4 the whole square. That's nothing but 2 squared. So 4 by 4 is nothing but equal to 1. So you will get c is equal to 1. So what's the equation you get here? Y plus 3 by x plus 4 the whole square is equal to 1, or in other words I can write it as y plus 3 is equal to x plus 4 the whole square, or y is equal to minus 3 plus x plus 4 the whole square. So this is the equation of the given curve. Got it? Yes.